Okay, after having your first encounter with some of the uses of the basic differentiation rules, for example, the power rule, etc., the constant rule, the derivative of a constant, etc. Now I want to show you something a little bit about notation. How do we write the derivative of a function, or how can you find that they want you to find the derivative of a function. For example, you might find, if you go to a textbook, you might find something like this. If you have a function y, then they can ask you to find dy dx. This is how this is read, dy dx. Okay, they are asking you to find the derivative of y with respect to x. Okay, that is one example. The other might be if you have a f of x and they want you to find the derivative of that function, you can find something like this. Okay, they are asking you to find the derivative of f of x. Also, you can find if your function is denoted as y or g, for example, you are going to have something like this, g prime. They are asking you to find the derivative of g with respect to x. Okay, and one last example, if you have a function f of x and you find something like this, then they are asking you to find the derivative of y with respect to x, or if your function is called f of x, you might find something like this. Okay, these are different ways that you can find in textbooks or in the internet maybe. Okay, and they're asking you to find the derivative of y, f of x, or g of x. Okay. Okay, now let's continue. We have, let's see what we have next. Okay, we have something like this. If we have something like this, there are examples that ask you to find the slope of the tangent line, or they ask you to see where on a curve at some point A, B, C, D, or E is the function positive, is the function, the derivative is positive, where the derivative is positive, where the derivative is negative. Okay, and one important thing is to find where the derivative is going to be 0. Okay, we are going to find where the derivative is 0 later on the course. Okay, but in this case, we are just going to find where our derivative is going to be positive, for example. Okay, the derivative is going to be positive here at this point A. Here A, here V. As you can see, the slopes are positive at those points, and E. Okay, that's it. In this case, f prime evaluated at those points, for example x1 in this case, x2 or x3, they are all positive. For example, x1, f prime of x2, or f prime of x3, they are all positive. Okay, and where the derivative is going to be negative is here at point C. Here, as you can see, the derivative is going down, the function is going down, so the slope is negative, so the derivative is going to be negative. Okay, so the derivative is going to be negative here. Let's call this value x4, and this one is going to be x5. Okay, so the derivative evaluated at x4 and the derivative evaluated at x5, they're all going to be negative. Okay, that's it. Now, some uses of the power rule, for example, if you have these functions, if you have in letter A y equals 5 over 2x to the third, or in the second example y equals 7 over 3x to the negative 2, okay, then I'm going to use the power rule to find those derivatives, but in this case you have to do something else, okay? One more step, just one more step, okay? What's that extra step that you're going to do here? Okay, what you're going to do is to rewrite your expression. Okay, this factor, you are going to write it up in the numerator. So you're going to have y equals 5 halves x to the negative 3, right? Because you are changing terms in a fraction, so the exponent is going to change in sign. Now you are going to differentiate. That means that you are going to find y prime. So what is that going to be? So you have a constant, you're going to write your constant, and you're going to multiply by the derivative of your function. In this case, x to the negative 3. So you're going to use the power rule. You're going to bring down that exponent as a coefficient, minus 3, and then it's going to be multiplied by x, and you're going to subtract 1 to your exponent minus 3, so it's going to be minus 4. And then you simplify. That means that I'm going to rewrite again without negative signs for the exponent. So I will have what? A negative 15 over or divided by 2 times x to the fourth. Okay, that's going to be your answer. That's your answer in the first example. Now in the second example, it's pretty much the same. You have to rewrite your function. So it's going to be y equals 7/3 multiplied by x squared. Okay, and again I just changed the sign of the exponent because I'm changing terms in a fraction. So now what about the derivative? Your derivative, you're going to find your derivative. What's that derivative going to be? Okay, you have a constant, so you write your constant, and then you multiply by the derivative of x squared. Some of you already know this. What is the derivative of x squared? You just use the power rule. You bring 2 down here, x, and your exponent is going to be 1. So that's it. And then you simplify, and what's the final answer? Y prime is going to be equal to 14/3 of x. Okay, that is your answer. Okay. In this case, as you can see, the extra step is to rewrite your function and differentiate. Okay. Now, in this case, you have an example. We work with some examples like this in class. They ask you to find the equation of the tangent line to the graph of this function f of x equals x squared when x equals minus 2. So in this case, minus 2, the point when x equals minus 2 is going to be this one here. Here it is, this point. So it's going to be minus 2, 4, that point. And they are asking you to find the equation of the tangent line. Okay, so the first step is to find the derivative, as you already know from all of the examples on the exercises that we have solved in class. The derivative is going to be 2x. Okay, if I use again the power rule, I bring down the exponent as a coefficient 2, and then I subtract 1 to the exponent, so it's x to the first. It's going to be 2x. Okay. Now, in order to find the slope of the tangent line, the slope of my tangent line is going to be my derivative evaluated at the value for x that they are giving me. The value, the x coordinate of my point. In this case, is going to be -2. So I will have to evaluate my derivative when x equals -2. So it's going to be 2 times -2. So the slope of the tangent line in this case is going to be what? -4. So that's my slope. And I already have my point. The point that I am working with is -2, 4. So as you remember, this is x1 and this is y1. Right? So I have everything I need. I just need my 2 coordinates of my point and my slope, and then I have to use my point slope form of the line, which is this one. Okay, the one that we have been using these last couple of weeks. So I just evaluate this form of the line with the values that I am given. Okay, my slope is -4. Okay, my x coordinate is -2 and my y coordinate is 4. So it's going to be y minus my y coordinate, which is 4. So I write it. It's going to be -4. This is my slope multiplied by x minus my x coordinate, which is -2, like this. So in the end, my equation, the equation of this line is going to be -4 multiplied by x plus 2. Okay, that is the equation of the tangent line. Okay, these are some examples that we are going to work with tomorrow. Okay. The good thing about these videos is that you can go forward, or you can rewind it every time as needed. Okay, you can pause it so you can understand everything for the subject tomorrow. Okay, thanks for watching.